Hi guys, I'm Łukasz, I'm lead Gen AI engineer, and today I will teach you how to run Qwen 3.5, the newest model that have multimodal capabilities and amazing benchmark scores, and everybody use it locally in the fastest possible way. Typically, people use Ollama, LM Studio, and so on to run the model, but this is not how you should run it locally with AI, but typically people do it because it's easy. And today I will teach you how to run it efficiently and in a separate environment like in Docker. Behind the scenes, LM Studio and Ollama use llama.cpp as the backend engine. So the first engine that we use is llama.cpp. llama.cpp is inference engine optimized by C++, as you can see by the name. And what it allows us is to squeeze every possible juice out of our hardware. So it will use GPU, CPU, offload things to RAM, anything possible, just so you can run the local AI model. And this is typically optimized in a GGUF format. And the only caveat is that the input for llama.cpp is only images, and the Qwen models have the video capabilities. So that's why we'll use vLLM. This is typically first engine that you use in light production and so on, because it allows you to better scale for multiple users at the same time. But the advantage is also that it has pretty big community. You can run models in int4 and FP8 format. This is a specific format that you need to check for your GPU. For example, I use RTX 6000 Pro. It supports int4 and FP8, but some older GPUs have only FP8 or even less of the support. And this engine also allows us to have as input the images and videos, so we can use the full capabilities of the Qwen models. And by hosting it on Docker and using these inference engines, we can squeeze as much as speed as possible. We have full control over all knobs of the parameters. It's super easy also to update and so on. And you can literally chat GPT prompt whatever you want. You can send curl commands to it to get answers from the model, and you can use it for your own projects. So let's dive into it. Okay, so the first question is, why Docker? Docker allows us to have a clean environment, reproducible builds, and basically I can share this file with you guys, and you can basically run it with one command or one click if you use Docker plugin. If you are curious, the Docker plugin is here. And now I will do a very quick overview. First thing, what image we use and which model. We'll go into downloading them also soon. And because we use the images, I skip some parts because we optimized it in many other videos before, so you can check it out. We need MMPro format for the images, because typically if you do only text, you need only this part of the model and so on. And we set up the context to maximum because we can. Because as I said, I use the RTX 6000 Pro. We can quickly check it. If I do NVIDIA SMI, you can see that I have RTX 6000 Pro. You need to install the drivers. You don't need QDA version locally through NFCC because the Docker will manage it. That's also why we use it, because we will not screw up the configuration there. And what I will also use is OpenCode. So I will use it to basically prompt the model. And you need to install NVIDIA CUDA toolkit, but basically all the requirements will be below because I repeat it in each video and so on. And then another image that we will use today is the 27 billion version in FP8, because I think that's what's most fitable in the hardware. I use this because it's quite big model, so we can check the capabilities. And as you can see, we need some special flags. This one is only for RTX 6000 Pro and Blackwells because there is issue on vLLM. Maybe it's actually fixed, but I still have it. And then we set the context length. Could actually set it up more. And we need to set up the flags for the image and video support, but you can basically copy paste it and use it. And well, how we choose models? Well, if you use llama.cpp, you can add your hardware in Hugging Face, and then it shows you each model sizes that you support. So as you see, I have a workstation version, 96 gigabytes of VRAM, so I can support basically everything. And also, if you don't know which quant to use, Bartowski, that I remember and use for quite a long time, always have a nice table when you can see, for example, that Q4KL is a good quality format and it's recommended. Now, how to download models. Basically, we need to create quick environment. I will attach the file so you can actually do just UV sync, but I will show it from scratch. So we do uni init. I already have it initialized, so I don't need it. And we create .env. Voila. Then we need to activate the environment. So you can just copy paste it here. Here we have it, and then we need to add our packages. Comment. As we can see, we added all the packages, but what we also can do is just UV sync, because this basically go to this file, and I already set up it for you guys, so it basically download all of these packages. And then if we come back to the script, I write the script that will download all the necessary files for GGUF and the vLLM version of the models. I use just this for. I try to download the last version, but it takes too much time to download all of this. So it basically check the dependencies, tell you what you need to do, download each models, then it downloads the specific file for vision that it's needed in the GGUF version, and that's it. So if I want, I can, for example, run it. I will do /Qwen models. So this is the script. And as we can see, it checked that I already have these models, so it skipped it, and then it should stop at the last model, So you can use it to download all the models that you want, because it's easiest. This, and I use HF transfer to basically have quicker tolerant rate. And your environmental variable, you just store HF token here outside of this folder, because then it automatically gets used from the dockers that I set up, which we see here. So I point to the environmental variable. I'll not show, you need to delete example because yeah, I will not show you my Hugging Face key. And that's it. That's how we download the models. Now, quick tip, if you will have some issues with vision and so on, this is documentation on llama.cpp, how you should set it up. And this is documentation on the actually vLLM with the newest Qwen 3.5 model and all the ways to run it. But it will all be in the GitHub repository under the video in the description, so you can check it out. So now, quick note, as I will use OpenCode, if you want to use it too, you need to set up local API in this directory. This is default directory. If you don't have it, you can create it. And then we have here also the file, how I set up all models, but I have quite a lot here, so you can check it out. But maybe let's look at one example. So yeah, we set up the Qwen model, input context, output, the input could be image, we specified here. And then I also created vLLM for all the models that I have here. And as example, here you see we have input text, image, video, but OpenCloud don't support video, I think. So that's why I will use just a curl command on the Python. So now if we do OpenCode, we are already in the model. And now when I switch to our Docker, I will start running it. So as you see, I basically by clicking here, I execute Docker compose, and then I go into the folder, compose up, and then the -- build. We can see it here. If I want to see logs, I can go either to compose logs or here. And we can see that this model already loaded. Okay, and now what I will do is I will just switch model to the one that I use. I think it should be in the top, yeah. And now I can do hi, which is very smart prompt. And if you can see here, my GPU starts spinning. And hello, how can I help you today? So now we need some image. Let's see what I prepared. Yeah, so I screenshot my local files, and now I can just do this and explain what is on this image. And now we see that we are getting, again, prompting and thinking. And this image show a file browser window, GNOME, displaying this. At the bottom, a file named is currently selected, highlighted. Here, if I go into it, we can see that I was highlighting this and it extracts all of this. Now, let's check. Yeah, I attached some notes that I'm very bad at writing myself, handwritten, so we'll see what is this saying. So basically, I attached here mixed English with Polish because I'm Polish. And actually, this is wrong. It's called the dog. I wrote wyprowadź psa, which means get the dog out. But yeah, as you can see, my handwriting is not perfect. If you can read this through, then you're better than AI. But maybe let's try again. So I thought it would be in context. Let's see. Okay, so it actually can't read it, which is interesting. So I guess my hand notes are pretty bad. And then we can see this. We can see my GPU slows down when there is inference. Ooh, that's actually pretty bad. But yeah, so this was my note for myself that I intentionally put like this. So let's try again, and let's say, so let's see. Okay, so actually this don't get this at all. So we'll see if the vLLM try it. Now this is example from the Qwen benchmarks. So what is this picture? So this was maze, and it should now help me to solve it. So let's see, go down along left, turn right, go up, turn right, go down, down, guess this is right, go down through the center, yeah, turn left, go down, turn right, turn down. So yeah, we solved the maze, so this is actually quite cool. And now if I try video, okay, so it's a bit cheated, it uses tools to just read what is the format of video, but yeah, it cannot play or view the actual video. So that's the limitation of llama.cpp. So before we go to the vLLM, I also forgot to show you guys how to do calls in Python, but before, I find this French text of a song and I will translate it, and we can see the translation. Okay, so there's a bit difference, but more or less it's okay. And now, so I make this script more like ChatGPT, but I use OpenAI to make the calls. So now if we look, yes, at our environment, I basically add OpenAI, and then it will be already here. So if you watch this video, you can just do sync and you'll have all packages. And now I just make a API call to the same engine running here. So it was quite fast. So you can see we got the message here, and then the result. Okay, so I use the image that it's number 2 PNG. I look at 2 PNG. Yeah, this is my image, and I can switch it to, for example, 5. So now GPU is spinning. Okay, So actually the output is not that great, but it's my handwritten note. But this is just a quick example, basically how you can call this tool. You can feed this and then optimize it for your own app and so on. So now we will look into VLLM. Okay, guys, I'm back. So I tested the VLLM. I deleted the maximum number of tokens because I can feed the full model, and I lowered the GPU memory utilization because I get the crash when I'm using OBS while recording and everything. So first let's do, yeah, this is NVTop, and we can do open code. Now let's ask, what is this picture? So yeah, so it answered correctly. Now let's see this. Okay, so this is not right. This, at least it no handedly right handwriting, which is true. So it couldn't recognize it because this model technically is in a higher version than the GGUF we use, I think. But we use the higher version of the model for GGUF. So okay, so it thought I'm writing it's Relita, which is funny. But yeah, my handwriting basically is too much for this model. Okay, so here I use again the script that I will provide for you guys in the description. So this time I make translation because I don't do it in OpenCloud. Basically, I ask it to translate this image. It takes much longer because I don't limit the output like in OpenCode. So basically, it was thinking more before giving the answer, and you can see the completion tokens here. The translation looks kind of all right. And then what will be the interesting part is to do this, which now, as you can see, we feed the video into the model. Also provided NVTop on the left, so you can see. This was pretty quick. Badges. So the video that I choose, okay, so this is the result of the video. We can see that there are two parrots and they are cuddling. This looks more like metal cage, but it's plastic, but this is okay. Let's check if the image is right. Okay, so it recognized the animal. Okay, so the second test, we will run it in the meantime. So what we'll do is that we want to find out what is the number on the shorts of this guy. I find this video from free sources, which wasn't so easy. The number 12 is visible on his left short leg. Okay, so it looks from our direction, so let's say it's left. So this is all right. Okay, guys, so to summarize, I wanted to show you how you can quickly wrap up something that will work with image, audio, and video. And I provided here multiple Dockers that I use. And I don't test all of them, but they are basically the same, just change out the model, so it should work all right for you guys. And when you think about it, this is quite a nice model because, as we can see, it recognizes a lot of tasks quite correctly, even if the player playing the sport. So you can, like, for example, have AI that summarize some action like a monitoring system in front of your home and so on. I think of doing something like this myself. So if you want, like and subscribe and write me comments, so we will do a project like this. And also, I think the quite important part is that this is the local model. So you can translate the documents from other languages or help yourself with understanding what's written in the document, how to interpret it and so on, because you can use API models for this or ChatGPT, but then all your private documents, and you probably don't blur your identification numbers and so on, go basically to US and so on. So it's not the safest. So local AI is quite good for it. And you can create it to do some complex OCR. Maybe you want to activate things with your hand moving up and down, but technically OpenAI will be better for this. But you can use, for example, this model to make screenshots because analyzing video is costlier, and then see what you do, some actions that it will recognize and so on. So this will be all for today. So yeah, see you guys in the next one. Bye.